Welcome to part 3 of our week-long introduction to Malloc, and now we're going to move into Malloc and structures. So hopefully the the Malloc is making sense and you're picking it up. Just think about it as simple as possible, and that is that you need memory from the operating system. You need to tell it how many bytes you need, and that's what you're requesting. And then you're using it, you're assigning it to a pointer, and then from there it's just a pointer. Okay, so Malloc is really just try not to overcomplicate it because it's not too complicated. Using Malloc and structures, same thing. It's going to seem like there's a lot. This is going to be kind of a heavy week or week and a half, but it's really just some practice, and it'll all make sense, and I think it'll come pretty smooth. But again, we got a lot to cover here in order to make it make sense. So hopefully, a 20 to 30 minute lecture video. I'll try to keep it short, but every time I say that, I always bust the time. So it's like quoting a project in the real world. I've learned over the years as a contractor that my most accurate quotes are usually the time that I come up with, what my gut's telling me, and then double it. And that's kind of what I'm doing to you guys. But I'm not doubling it. So, but anyways, all right, I'll get into it. So when we look at Mallocing memory for a structure, the process is actually very, very simple. It's very similar. All we're doing is we're declaring a pointer to a structure type, and then we're using Malloc with our Sizeof and typecasting. Okay, so there really isn't anything different. Once we've Malloc the memory for a structure, then we use that structure because it's a pointer. We just treat it as such. It's a pointer to a structure, and so we use the arrow operators. So here's some example. This won't be the same code that we look at, but just another, just a way to look at a couple of different samples here. Here you can see we have our Malloc call, and we have our Sizeof call. The argument, what we use for Sizeof, is struct card. Okay, when we declare a variable, a structure type variable, we use struct card. When we want to make that a pointer, we use struct card and include the asterisk. Okay, struct is the keyword, card is the name, it's the identifier tag, so it's the name of the structure that we've created. So that's what we provide here, struct and card. So struct and then whatever the identifier tag for the structure that we want to get the size of. Typecasting, same thing. Okay, remember what I've been saying is that you can just use this value here. So we can do the same thing. We can typecast that Malloc call using struct card and then our asterisk. Okay, so we're saying take this void pointer that you're returning to me, and I'm going to use that memory for a struct card. Once we have, get rid of some of this clutter here. Once we have that pointer, that memory address, then we use, because this is a pointer, we use our arrow operator. Remember with structures, these are our members, and how we access, there's two ways we can access members. We can use the dot operator and the arrow operator. We use the arrow operator with pointers. This is what we have. Remember, every time we use Malloc or calloc, we have a pointer. When we don't use a pointer, when this variable is not a pointer, then we use the dot operator. Okay, so everything we use when we use these structures, having Malloc memory for it, we use the arrow operator. Let's see, a couple things here that are not included in this code. Okay, don't forget to check for null. And my penmanship is really bad. It's not just the fact that I'm trying to write on a tablet. And we also, when we're done, we need to free. Okay, so don't forget those two important steps when working with Malloc and those pointers. So let's see, there's free, and there'll be some practice we'll talk about. In the slide deck, I include a slide for realloc, but we're not going to talk about it. We're not going to use it. So it's just there for reference. Don't worry about it, though. I won't ask you any questions or anything about it. Practice lab, so these will be the practice labs if you're interested. Go through these programs. You can submit the code to me at any point in time. I would love to take a look at it and help you work through any troubles that you're having. I try to make these practice labs, especially as we move into some of the more complicated topics, I make them a lot closer to the lab itself. So if you'd like some feedback from me, please go through this and write the program and send it to me. How you write the program, you can try to condense it all into one program. You can do it in multiple. It doesn't matter to me, as long as I got code to look at. Okay, so let's go look at some actual code. We're going to go back to that same file. So structures in malloc.c, that's the file that I've uploaded. And What I've done with it is it's kind of a large file because there's a lot of sample code in here, and I just went through and commented out the portions that produce output. So any of the printfs or the puts for the most part, I went ahead and tried to capture all those and comment them out. That way you have all the code. We've talked about all this code, but it's not generating a whole bunch of output to clutter up our terminal window. What we're going to look at here in particular then are these, the structure and these two functions. Okay, right off the bat, okay, so just as a refresher, I guess, how do we declare a structure? Well, we declare it outside of main, and we use the struct keyword. This is our identifier tag, so whatever we want to call this structure. Our members then are defined inside of these curly brackets, and then the closing curly bracket is ending with a semicolon. Okay, with these members, we don't initialize them to anything, we just declare them. Okay, so if we're declaring an array, we have to declare the size. If we're declaring primitives, we just declare what we want that member to be named, so it's like declaring a variable. We'll look at pointers here in a second as just a refresher. We'll declare some char pointers or some strings. Here are two functions then, printEmployee2 and printEmployee, and we'll look at those as well, and you can see that these are the arguments, one argument, and it's just how we use struct. Excuse me, just lost my train of thought. It's how we'll pass struct types as arguments. And let me just double check some code here because I'm pretty sure we already talked about that. Oh, that's the wrong file. Right, yeah. So structures intro.c. This will be, you know, kind of a refresher then. Because we did talk about them. We have, in fact, I use the same exact functions. So we have struct employee and struct employee2. Okay, so we did talk about structs as argument types. So it's really just largely going to be a review. All right. So how do we even do it? How do we malloc memory for a function? So we're going to scroll down to the very bottom of this program, so the very bottom of our main function. And here I'm going to highlight this section with this comment here. So here's malloc and structs. And so the main purpose of this is just to how do we malloc memory for our structures? Once we figure that out, the rest of it is stuff we've already talked about. So recall that when you declare a struct variable, this is how we do it. Let's say that I want to declare a employee variable and I want to make it a struct employee type, and then I initialize this values using an initialization list. So if we go back and look at those members all the way to the top, we have a char array for first name, a char array for last name, int for age, and char for gender. Okay, so scroll back to the bottom and you'll see there's a string value for first, string value for second, int value for age, and a char for the gender. Okay, this is not a pointer. So if I want to access those members, I do something like a employee dot first name, right? And that's how I access those members. It's not a pointer, so we're using dot notation to access those members. Well, what about using malloc? That's the purpose of this. The first thing we're going to look at then is this printf, and I'm just simply going to print off. There's a little more room here. I'm just going to print off the size of struct employee. Okay, just like when we use int or char or double or float, when we look at the malloc call itself, when we do the typecast, we have to use struct and then the identifier tag. Struct itself isn't enough because that's not specific. The compiler wouldn't know if you have multiple structs defined in your program. So you have to, employee wouldn't be specific on its own enough. Employee wouldn't be a complete type. And so you have to use both, struct employee. And so what you're going to see first, the first thing we're going to focus in on is what is the size of struct employee. Okay, so let's go ahead and run this program and see what we get. All right, the size of struct employee is 48 bytes. So is that what we were expecting? Well, let's go up and look at our struct again. Okay, we have a char array with 20 elements. We know that a char, on my system at least, is 1 byte. So that's 20 bytes for first name, 20 bytes for last name. That gives us 40 bytes. We have an int variable, 4 bytes for that, so that's 44 bytes. And then we have another single byte for that char. So it's 45 bytes. 45 bytes, and when we looked at the value of Well, what's the value of the size of struct employee? It said it was 48 bytes. Okay, so the point of that is that you can't just simply, again, you want to use Sizeof. If we just added those up and said, oh, it's 45 bytes based off of the members, and then we malloc with a size of 45, instead of using Sizeof, we'd have problems. Our program wouldn't work, it wouldn't work correctly. And so 48 bytes instead of 45, you can't just simply add up the bytes that the members need and say that is how much memory I need to malloc for that structure. You need to use the Sizeof because there is some overhead in that structure itself. The system is going to get a little bit more memory than what you'll add up, and you probably cause, you can get some unexpected behavior in your program. So just like with ints, just like with any other type, we want to use the Sizeof operator. So how do we use that to malloc memory for a struct? Well, this is just like declaring a pointer to a struct employee. We've already covered. Here's our malloc call, and then there's that same Sizeof. Okay, and that's all we need. So now that will allocate enough memory for that structure. That'll give us first name, last name, so 2 char arrays of 20 elements, 4 bytes for that int, 1 byte for that gender, and then some miscellaneous bytes for the overhead of the structure itself. This is how we typecast. Okay, so if you just copied everything from the asterisk back, that's what the typecast would be. And now we've malloc memory for that structure. It's that straightforward. Once we've done that, now we're just dealing with the structure. Okay, so the last few minutes here of the lecture is really just largely just a review. Although there are a couple things I do want to point out that are specific or unique to working with malloc structures. First of all, well, let me back up one more thing. I want to point this out before I forget. And again, I'm pretty sure we covered this in our structures talk, but just to show you, let's say that I have 2 functions. They have arguments, are struct employees, and I declare those prototypes before I declare the struct itself. If I go to compile that program, you'll see there's a ton of errors. The problem is that I've tried to use that struct employee before I've defined it. Okay, so if anything is dependent upon that structure, then that structure needs to go first. So odds are, the way I like to organize my programs, structures, then prototypes, that put in my symbolic constants up at the top, and then main, and then below main, I've defined I implement all of my custom functions. Okay, so jumping back down to here, if we look at, let's see, go back to that structure. Okay, we have first name, last name, age, and gender. Right? First and last name are char arrays. So if I want to access those members, this struct's an employee. So all I need to do is use the arrow operator. If I try to do something like this, okay, we covered this in the structures lecture, this is going to generate an error. Let me clear the screen here, clear the console. Okay, an error, incompatible types when assigning. So remember with that, we can't do that. If we want to assign a string value to an array, a char array, then we need to use our string copy. So what we're doing here then is I'm going to assign the value of Fred to the first name member, which is our char array, and I'm using string copy. So the format, 2 arguments, okay, where do we want the data to go, and what data do we want to put there? Okay, so now I compile, that compiles clean, and we can run the program, and you can see I just printed off the name Fred. So I just printed off that first name member. And you can do that with the puts. Puts just adds a new line. Again, this is a pointer, so we use the arrow operator. All right, what if, all right, so first name, last name. You can do that with both. They're both char arrays. What if I go back to that structure, and instead of making last name char array, I declare it as a pointer. Okay, if you go think back to our lectures on strings, we could do something like this. We could say char, string 1 equals blue. Right? We can assign a string literal to a string pointer, and that'd be no problem. So it may stand to reason that couldn't I or shouldn't I be able to just simply do something like a employee last name equals, and I'll just use my last name. You would think it would. So let's see what we get when we try to compile that. Oh, we get code to run. So struct employee and last name. Okay, so there's no problems there. Give me 1 second here. I gotta pause. Okay, sorry for that interruption. So what I changed was, if I change that member to a char pointer, I can still access that member through the arrow operator and then assign it a string literal value. If I go ahead and try to print that last name, okay, we'll use that on line 112. We'll print it. You'll see that there's no errors with that. So it compiles and it runs, and there's the printing of my last name. We're to the point in the program now where I'm prompting for a last name. So let's just say I type that in. I'll put in 2 just to show that it's different, and I get a seg fault. What did I do in my code? Well, inside this code, you can see that I have scanf using %s. So that's just how we try to capture a string value using scanf. Remember the limitations of scanf. That's why we've introduced and used both scanf and fgets. And I provide a employee last name. Okay, we don't need the address operator because this is a pointer. But when I do this, this is when I get the segmentation fault. So as you probably guessed, the code above it is the fix for it. And so what happens when we assign this, this is a legal thing to do. This is legitimate. This works. This doesn't generate any errors because at the point in time that we create that string pointer, that char pointer, the program, C itself, the runtime, will make sure that that value gets stored in memory. When we change here, what happens is that it's not being treated the same way. This pointer doesn't have a memory address yet. And so here it gets taken care of. Okay, when we declared those strings, we never had to worry about Malachy memory for it. Remember, it just worked. But here that's different because scanf needs a memory address. It needs to know where it can store that value. And so what happens is we actually need to malloc memory for that member as well. Okay, so this is what we're doing here. And I'm going to say that's a char pointer. So size of, char, and I had those be 20 element arrays. So this will give us the same amount of bytes, so 20 bytes for that value. And now when I run this program, it's going to work. And you'll see that it'll prompt me to enter my last name, it'll prompt me to enter my age, and then we'll print the last name again, and we'll print the age. So let's go back to the command line and see if that in fact fixed it. Okay, so I'll add 2, and I'll add my age, and there we go. We ran with no errors, we got no seg faults. It printed off Stroshine 2, so I know that it accepted the value that I typed in as well as my age. Okay, so when you do this and you assign it a value using a string literal directly, that's going to work, no problems. If you try to capture that information using scanf, you need to make sure that that member has memory malloced for it. So not only do you need to malloc the memory for the structure, you'll need to malloc the memory for any of those members that need it. If you want to just use char arrays, that's fine. I have no problems with that. I'm not saying that you have to use pointers in your structure. Use whatever you want. Just know that if you do decide to use a char pointer or a string pointer, you may need to malloc memory depending on how you use it in the program. The last thing just to look at here is you'll notice here I use parentheses. I create an order of precedence on the arrow operator. And so by not doing that, this gives us the address operator on this member itself. Okay. If I didn't do that, then I believe it gets the address operator for the structure, and that's what would cause you some issues. So when you need to get the address of a member, you need to put that member inside the parentheses and then use the address operator. Let's see, and then that's pretty much it. That print off the members there. Okay, remember that structure is a pointer. Everything that we do with malloc, calloc is going to be a pointer, so we need to use and treat that just like we would a pointer. In the case of the struct, we use the arrow operator instead of the dot operator. We have these 2 functions, and I'm not actually going to call them just because we've already talked about them. The only thing this is showing is just a reminder that Once you've malloc memory for that struct, okay, it doesn't matter that we malloc memory for it, other than it's still just a pointer. The only thing that matters is that when we're done, I need to remind myself to free it. Okay, so I'm absolutely sure I'm done with it at the end of my main function, and that's a pretty safe statement, pretty safe assumption. I need to free it. As far as the functions go, doesn't matter. Okay, we've got, this is where it's declared as not a pointer, just a variable of that type, that struct employee, and here it is a pointer. The only difference inside of these functions then is that I use the dot and the arrow operator respectively. So we're not actually going to really talk about those because we already have, so those are just there for reference. If you wanted to use this code then, use the structure that we've defined here, use the malloc call, and then be able to pass pass that struct, that variable, using either one of these. You need to use in the lab, you need to use a pointer, so I'd focus in on this one. That just helps to make sure that you're doing everything correctly. So again, if you have any questions, let me know. Otherwise, this wraps up, again, a rather long sequence on talking about malloc. Hopefully, it's all making sense and that you actually kind of enjoy it because it's kind of fun. All right, thank you.